Hi, hello everyone. Welcome to My Life is Math Learn channel. Today we will discuss about different forms of a complex numbers. In the first form, coordinated form. Here we are represented as a z is equal to x plus iy, and where x comma y are real numbers. So in the coordinate plane, x is the real and y is the imaginary. X-axis is real, y is imaginary. So the point located, every complex point located as a x plus iy. Next form, polar form. We can represent a polar form. It is the every complex number is in the form of x plus iy. So and from the origin, the line makes the angle theta. So we can make a triangle on the positive x-axis. Now it is makes the one right angle triangle. Cos theta is equal to hz by hypotenuse. Therefore x by mod z, where the distance from the origin to point is a mod z. We know in previous video we are learned about that one. So cos theta is equal to x by mod z, and sin theta is equal to y by mod z. So x is equal to mod z of cos theta, y is equal to mod z of sin theta. So replace the x and y in the general form. X plus iy, I will replace x as mod z cos theta and y as I into mod z sin theta. Z is equal to, let take the mod z is a r, it is a distance, so r cos theta, r sin theta plus r sin theta. Take r common, cos theta plus I sin theta. Z is equal to r into cis theta. Cos theta plus I sin theta means cos means c, I means iota, I, sin means s, cis, cis theta we can call. Next form, Euler's form. Z is equal to r into e power I theta, where e power I theta is cis theta. So z power n is equal to r power n into e power I theta whole power n, r power n into e power n I theta. So r z power n is equal to n into r z. z1 into z2 is equal to r1 r2 e power I theta 1 into I theta 2. There is equal to r1 into r2 e power I theta 1 plus theta 2. So rz1 z2 is equal to theta 1 plus theta 2. So theta 1 means rz1, theta 2 is equal to rz2. So rz1 plus rz2, conjugate form. If z is equal to x plus iy, then z is equal to x minus iy is the conjugate of given real number. If z is equal to x plus iy, then z is equal to x minus iy. So x plus iy and x minus iy is both are different directions. So z is the x plus iy, z bar is x minus iy. It is a conjugate of x plus iy. Notes, important notes. Point 1. Z plus z bar is equal to x plus iy plus x minus iy is equal to 2x. There is equal to 2 real part. X is the real part. 2 real part of z. Z minus z bar is equal to x plus iy minus x minus iy. There is equal to x plus iy minus x plus iy. So x cancel, plus 2iy, sorry, plus 2iy. So 2 of imaginary part of z. Next, z bar is equal to z. Z is a purely real. Z bar is equal to minus Z. Z is purely imaginary. Z into Z bar is equal to mod Z square. There is equal to x square plus y square. These all are important formulas. You have to remind it. And Z comma Z1 comma Z minus Z comma minus Z bar, it makes a one rectangle. Seventh one, two complex numbers are said to be equal if their corresponding real parts as well as imaginary parts are equal. x1 plus I by 1 is equal to x2 plus I by 2. Then x1 is equal to x2 and y1 is equal to y2. Then it is a equal. Z1 is equal to x1 I by 1. Z2 is equal to x2 I by 2. So Z1 plus Z2 is equal to x1 plus x2 plus I into y1 plus y2. Now Z1 minus Z2 is equal to x1 minus x2 plus I into y1 minus y2. Z1 Z2 is equal to x1 minus I1 by 1 into x2 minus I by 2. After producting, we will get x1 x2 plus I by 1 by 2 plus I by 1 by x2 plus I square y1 by 2. There is equal to x1 x2 minus y1 by 2 plus I into x1 y2 plus y2 x1. Next, Z1 by Z2 is equal to, if you get in the denominator imaginary number or complex number, you must be rationalized. So x1 plus I by 1 by x2 plus I by 2, rationalize it. After rationalization, we will get x1 x2 plus y1 y2 plus I into x2 y1 minus x1 y2 by x2 square plus y2 square. Next, complex numbers in argued plane can be treated as a vector. So here complex numbers, it was treated as a vectors. Suppose origin O and P is the point, the OP bar represent as it is a vector. So mod Z is equal to mod of OP bar, and P and Q are 2 points, Z1 and Z2. So PQ is equal to Z2 minus Z1. So mod PQ is equal to mod of Z1 minus Z2. The mod PQ bar is equal to, the distance of PQ is equal to square root of x1 minus x2 whole square plus y2 minus y1 whole square. Let's solve some questions here. Find the locus of which is satisfy relocation of mod of z minus 2 is equal to z minus 4. It is a bisector formula. So I will draw the diagram. 2, 0, 4, 0, 2 points. In the x, 0 is the our required point. So it is a line. So if z is equal to x plus iy, so x minus 2 plus iy mod is equal to mod of x minus 4 plus iy. So x minus 2 whole square plus y square is equal to x minus 4 whole square plus y square. Because of mod z x square plus y square formula you can use. So y square cancel. X minus 2 whole square is equal to x minus 4 whole square. So after squaring, x square minus 4x plus 4 is equal to x square minus 8x plus 16. So x square cancel. Minus 4x minus 8x. 8x minus 8x get here. So 8x minus 4x, it is equal to 4x. 16 minus 4, 12. So x is equal to 12 by 4, that is equal to 3, and x is equal to 3. Note. Here note what we discuss, those point of view here coming. If the z modulus of z minus z1 is equal to z minus z2, z is the perpendicular bisector joining the segments. Find the locus of which z is which satisfy mod of z minus 2 plus 3i is equal to 4. It is appear like a circle equation. Let's solve it. Z means mod of x plus iy minus 2 minus 3i, so is equal to 4. X minus 2 plus I into y minus 3 is equal to 4. Squaring on both sides, x minus 2 whole square plus y minus 3 whole square. We can use the mod of x plus iy formula. X minus 2 whole square plus y minus 3 whole square is equal to 4 square 16. So here it is represent a circle equation. So mod of z minus z1 is equal to a. Z is the locus of a circle with center z1 and radius a. Thank you for watching. Please subscribe our channel to support us.